welcome to 3.3 example B. Before we do, let's talk about the equations for Manish's workout from our investigation. Alright, you came up with the equation y equals 215 plus 3.8x, or you could have also written as y equals 3.8x plus 215. It doesn't matter which one of these two terms comes first, if it's 3.8x or 215, because it's the same thing, right? 5 plus 3 is the same as 3 plus 5. Okay, so I know that they're the same, so it doesn't matter which equation we have. And these two equations are actually written in something called intercept form. Alright, so we have intercept form, which is of this form, y equals a plus bx. And we can actually switch these around, and it doesn't matter what the a is and what the b is. I mean, I can really use any letter. You might have heard y equals mx plus b. You might have seen that before. It doesn't matter really which letters we use, as long as we know the first term right here, the a, that doesn't have an x with it, where it's going to be one thing, and this b is going to be something else. And this a is actually called the intercept. All right, it's intercept, and it's short for the y-intercept. Okay, and if you remember from what we did before, that y-intercept is really that starting value, right? So we can say the intercept is the starting value. Right, which is really where we start on the y-axis. So I've asked you a bunch of questions in class about this kind of stuff. The y-intercept is the starting value. It's the number that's on the y-axis. It's where we start on the y-axis. Okay, so that is the intercept. It's the number without the variable. So then this b is our coefficient. That's also the recursive rule, right? Recursive rule. So let's make sure I can write this right. Recursive rule, right? When Manisha went 3.8 calories per minute, that's our recursive rule. All right, that is our coefficient. That was how much we went up. It's the slope or the steepness of our graph, right? It's the steepness of the line, okay? And that's the coefficient, the number with the x. So it doesn't matter which letters you really use. You might see a and b, you might see m and x, or m and b. You might see all sorts of different things. As long as you know the intercept is the one without the variable and the coefficient is the number with the variable, you're going to be just fine. Okay, so let's do this example right here. A minivan is 220 miles from its destination, Flint. It begins traveling towards Flint at 72 miles an hour. Define the variables and write an equation in intercept form of this relationship. So it has to be in that a plus bx, okay? And it could, again, any letters you want. So define our variables. So what I'm going to do is, if I don't know what variables I'm going to use, what really helps is looking at our rate, because we have miles and hours. If we say how fast it's driving, then we probably know these are the things we want to use, all right? So I'm going to let m equal the miles from Flint, and I'm going to let the, let's say h stand for hours of travel. Okay, so let's write our equation here, part A. So I'm going to say the miles is going to equal, it's kind of like my y value, and the number of miles that I am from Flint depends on how long we've been traveling, right? Well, where do they start? We start at 220, so I'm going to start with this 220, and we're getting closer to Flint, right? So we're going to be subtracting 72 miles per hour multiplied by the hours. So it should be 220 minus 72 times h. If you don't want this multiplication in there, I would rather have you write it like this. M equals 220 minus 72h. Alright, that's just a little bit cleaner. We don't have extra symbols. It looks just a little bit better. Alright, so let's do part B. I'm going to do this in a different color to kind of separate what they look like a little bit. So it says, use your equation to calculate the location of the minivan after 2.5 hours. So I'm going to put this 2.5 in for this h right here. So I'm going to have m equals 220 minus 72, and instead of using h, I know that's going to be times 2.5. Some people like to put these in parentheses. Some people like to have it just as a multiplication, and either one is okay. Alright, so when you go through and you get that, you should find out that the number of miles is going to equal, that's right, it's going to equal 40 miles. Alright, so it means it's going to be 40 miles from Flint. Alright, then let's do part C. I don't have enough room, so I'm just going to erase this part here. That way we can keep on going. I want to keep my equation for part A. So now what we have is, use your equation to calculate when the minivan will be 130 miles. So I'm going to have, part C, I'm going to have 130 in for the number of miles, 130. And then I'm going to keep going with the rest of it and say that equals 220 minus 72h. So what I want to do is solve for h. Okay, so if I want to do that undo table, I could first h, then multiply by negative 72, and then add 220. So that means I have to subtract 220, and then I want to divide by negative 72, and then I will find out where I started. Okay, so if I take 130 and I subtract 220, I get a negative number, but then I'm dividing by a negative 72, and I'll get my answer. So therefore, I should get an answer of 1.25 equals h if I follow this. So 130 minus this, divide by this, I end up with 1.25. So that means that's a little less than an hour and a half. It's not 25 minutes, right? This isn't 1.25 minutes. This is 0.25 of an hour, so it's really 0.25 out of 100. We could change this around, but it's less than even, it's like 1 1/4 hours, really, right? So that'd be 1 hour and 15 minutes. Okay? And then part D, graph the relationship and locate the points that are solutions for part B and C. And what is the real world meaning of the rate of change? Well, let's just do part E. The real world meaning of this rate of change is the speed, right? How fast they're driving. And what does the sign of this rate of change indicate? Well, we have a negative 72, so that means they're getting closer together. So let's look at the graph. All right, so let's look at the graph. So what I've done here is I've graphed it on the graphing calculator. I think that'll be fine. So you don't actually have to graph this one. Let's just look at this together. All right, so if we want to locate the points to the solutions part B and C, well, let's just look at the solution for part C. I'm looking for 1.25 hours. Okay, so what I'm going to do is I'm going to hit trace. And I want to have, oops, I don't want that. I want right here. So I want to look for 1.25. I'm at 1.75. So let's go back a little bit. 69, 67, 64, 61, 65. And I'm right here at 1.24, which is really close. If I go up, it's 1.27, so this is as close as I can get, and I've got 130.27. So if we look at our answer, we had 130, so that seems right on. So I can just kind of check to make sure that one is okay. And then we also wanted to look at the other one for part B, and we said that part B was 2.5 hours, or 40 miles, right? So let's just check those. So here we are at 2.5 hours, and it's about 40 miles. If I go back, a little under 2.5, and it's a little over 40 miles. So we can say, yep, we got this right according to this graph. So again, you don't have to graph it, just check this one out. That way we can save some time. All right, so there are your answers for example B. Good luck with your assignment.